Hi! So this is my first video in the Math 1015 series. This is going to cover the homework and concepts for 1.1.1. And I will just hop right into it. This one is fairly easy, so I'll try, I'll go very slow on the newer problems. And then I'll just kind of speed through on some of the older problems. So if you are still having confusion after this video, please let me know. I'm available through text, and I'll respond as quickly as I can. Okay, so this question here asks us to find the coordinates of the points plotted below. So we have A, B, and C. Now, when we are graphing and finding points on a Cartesian coordinate pair, we are looking for an xy coordinate. So it goes x comma y. This is a coordinate. We go, okay, which one is it? Our x value, x goes from left to right, and y goes high to the sky. There's not really a fun rhyme for x. So when we're looking for a coordinate, we have a here. We go over 2, so our first point, our x, is going to be 2, and then we go down 3. So we'll go minus 3 for that. And then, and then for our b, we go over 2, up 3. So we'll do negative 2, positive 3. And then for our c, we'll go over 4, up 0. So over 4, up 0. And that would be your answer. Be sure to have them in your coordinate pair with the parentheses and the comma. Otherwise, it might get picky. I've used MyMathLab and Hux before. This is my first semester using Lumen, and so far I'm a little bit unimpressed. It's very, very picky. You just got to be really careful with the stuff that you put in, just to be sure. A lot of the times, so when I was going through this, 9 times out of 10, when I was getting an answer wrong, a problem wrong, it was just that I had the formatting wrong. So be careful with that. Now this one is telling us to write the interval indicated by using an ordered pair. Another concept that we'll be talking about is when we are thinking about domain and range and intervals and stuff, there are 2 different notations. So the notation that this problem is asking us to write it in is an interval notation. So that basically means that if you have a parentheses, that means it is not included. And if you have a bracket, that means it is included. And typically, when you see parentheses, that's always going to be infinity or negative infinity, and also greater than or less than with no equal sign. Is included is basically anything that has greater than or equal to, or less than. Sorry, I messed up the order, but greater than or equal to and less than or equal to. So say you have something like x is greater than 3. We will look at 3 here, and we can have our table of values, x and then t or false. If x is equal to 2, is 2 greater than 3? No, 2 is smaller than 3, so that would be false. Is 4 greater than 3? Yes, 4 is greater than 3, so that would be true. Now, is 3 greater than 3? No, that's false. 3 is equal to 3. If it was equal to, under our sign, then that would change it to 2. But since 3 is not included in this set, we're going to make a little hollow hole. We are including 3. And then we'll say it's going this way because 4 counts, and 5 counts, and all the way to positive infinity. So the way that we would write that would be 3, and we are not including 3, so we'll use a parentheses to positive infinity, close parentheses, because you cannot reach infinity. You could name a number, and I could name you a number bigger than that, so you're never going to reach infinity. Now, if it was greater than or equal to, we would just change this into a colon. Now, it's not like there's a super mathematical reason why they haven't decided that. It's just they are coming up with words and language to convey concepts. So, parentheses denote it is not included, and the square brackets mean that it is included. Now, with that in mind, when we're talking about this problem, we are saying that we are including 7, and that implies that we are not including 5. So we start from smallest to largest, so -7 is smaller than -5, and we'll do a square bracket because it is greater than, is including, and then -5 is not included, so we'll do a parentheses. Same for here, 5, 8, -6, -5, and that would be your answer. This one is the same principle that we were talking about previously. So we want to sketch the interval -2, 4, and it is both parentheses. So we are going to be using this one right here, the empty circle. So you'll put it on your 2, and then you'll put it on your 4, and then you'll click this, and you'll drag it to each other, and that would be your answer. Write the set of all integers between -1 and 4. Use a list and use commas to separate your entries. So this basically is saying, number 1, we want to make sure that we are doing between 1 and 4. So that does not include -1 and 4. So we'd say 0, 1, 2, 3. That would be our answer. How many elements are in the set of senators who sit on the U.S. Senate? So sometimes you'll see problems like this on there, where it's asking you to have a general knowledge of outside things that are not related to math. If you don't know how many senators sit on the U.S. Senate or how many counties there are in Utah, feel free to look it up. In this case, there are 100 senators on the U.S. Senate. This one is trying to trick you. How many elements are in the set of integers between -10 and 10? You would think that you would just count all of them. So you would think like, okay, 1, 2, 3, 4, 5, all the way. You'd say, okay, we have 21, except for we are still looking at between -10 and 10. So we are not including these. So we'll minus 2 from 21. That will give us 19 elements, and that will be your answer for that. It's trying to trick you because, number 1, you'd have to count 0. So even if you were thinking that it was including -10 and 10, you would say, oh, there's 20 there, because it makes sense. But you're actually doing 21. But even then, you are not including -10 and 10. Now this one is telling us that the following graph represents a relation. Identify the domain and range of the relation. So what we want to do is we say, okay, here's -5. So we'll say -5. Here is -1. Right here, -0, and then 3, and then 5. That's all of our x values. Now we want to care about where they are on the y. So we'll say we have, and we typically like to go from smallest up. So -4, -3, -2, -1, +3. This one is telling us to identify the domain and range of the following relation. Now this one looks wonky because it's not like something we've seen before. But basically, these are our outputs, and these are our inputs. So for other way around. My bad. These are our inputs, and these are our outputs. So typically, domain, when we're talking about domain, it's talking about our inputs or our x values. So we'll do 0, 1, 2, 3, 4. And that includes all of these. However, this 2 is not used and this 8 is not used. So we'll leave them out. And this 0 is used twice and this 6 is used twice, but we only need to list them once. So we have 0, 4, and 6. And that would be our answer for that. Write the domain and range of the following graph in interval notation. Now, this will stretch on to positive infinity and negative infinity. So we'll say negative infinity. Oh, and we can't do a square bracket for that because it's infinity. So negative infinity, positive infinity. And then for the range, it's going to be our lowest point is, and we are including this 3. We are including this 3. So it'll be 3, square bracket 3, comma, positive infinity, parentheses. Write the relation given in the following graph as a set of ordered pairs. Separate each ordered pair with a comma. So this one, it's very tedious. I'm not going to do the whole thing. You just want to say, okay, this point is -4, 0, comma, this point is -3, 1, comma, You fill it all out and your curly bracket. And yeah, if you get this wrong, first what I would do is I would double check that there's commas in between each point. If that's still wrong, I would check to make sure you don't have an extra comma in front of your y value in your ordered pairs. If that's still wrong, check your coordinates again and make sure you have everything correct. This one's telling us to fill in the blanks to write the domain and range of the following graph in set builder notation. Now this is where some people get confused, and I was initially confused because I was unaware of how Lumen wanted you to deal with it. So basically, when we're talking about set builder notation, it's really weird. It's like a new language. When you're learning new math concepts, it's really just like learning a new language. This looks really weird. This looks really wonky. But basically, what it means in English is our set, which we are naming A, includes or is equal to a number such that that number is an element of, typically you'll put like all real numbers or blah, 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 like that kind of stuff. So like is an element of all real numbers, and that number is like greater than or equal to 3 or whatever fits in that state. That could also be like x, any a set is equal to any element in our set such that that element is an element of all U.S. states. So then that list would be comprised of all the U.S. states. So like Alabama, Alaska, like all those ones, you know. It doesn't have to be numbers. We're basically just talking about what is in this list, and it's a fancy math, crazy way of showing what is in that list. So in this case, our domain, we go to negative infinity to positive infinity, right? But that actually is just all real numbers. And when we're talking about real numbers, we're talking about anything that you could put on a number line. So you could put like 0, you could put -1, you could put 2/3, you could put the square root of 3. Any number that you could put on a number line will work as a real number. And that is included in negative infinity to positive infinity. Now, our range, we know that our range, we can't go below 2. So our y has to be greater than or equal to 2. So it already has as an element of real numbers because it's talking about positive infinity here. But we also need to include that y is greater than or equal to. Don't forget that equal to sign because this is included 2. And that would be your answer. A common mistake here is that they forget to put the equal to and they just do the greater than. Here's this one. Fill in the table of values for the following relation and then graph the relation. This one we're basically just plugging in something for x. So we'll plug in -2 for x. That will give you -4 minus 4, so -8. -1, you'll get -6. 0, you'll get -4. 1, you'll get -2. 2, you'll get 0. And then when you would graph it, you'd basically just do like, okay, here's this, and then this, and then this, and then you'd like make a line. I know this video went long. I just wanted to explain everything in depth. If you have any other questions, please let me know. I will be available to text throughout the day. So yeah, have a good one.